there's different kinds of notations that we're going to use that we've already in fact used when we talked about domain and range on our parent functions. Okay? But I need to make sure you understand some things before we go on. Okay? You guys ever heard of natural numbers? Have you ever heard of counting numbers? It's another name for natural numbers. If I said, what are the counting numbers, what would you say? Yeah, 1, 2, 3, 4, 5, and so on, right? It's like 1, 2, 3, and on and on and on. Okay? That's one set of numbers. Okay? There's another set of numbers that include all of the natural numbers. And these are called whole numbers. See how the natural numbers set sits inside of the whole number set? So what is a whole number that's not a natural number? Well, in this particular case, there's only one. There's only one number that's a whole number that's not a natural number. Yeah, 0. Okay? So is the number 2 a natural number?
Yes.
Is it a whole number?
Yes.
Yes, because it's sitting inside that whole number set. You see that? Then there are some more numbers that include all the numbers we've talked about so far. And they're called integers. So everything inside this circle right here is an integer, as well as being some things that are more specific. But what do integers include that whole numbers do not? Close and yes. -3, -2, -1, and so on. Yes? Okay. Then there's this set right here. That are called rational numbers. What do rational, wait, what does this word mean to begin with? Yeah, we talked about it the other day, right? Ratio, and so it's a fraction. And so, do you see that rational numbers include fractions? Fractions like what? 1/3? 1/2? Is that what you said? Yeah? 1/2? What about 7/5? Does it include that? Yeah? Okay. We're good with that? Rational numbers are any number that can be written as a fraction. Then we have this section over here. Irrational numbers. Guys, if rational numbers are numbers that can be written as a fraction, what are irrational numbers? Numbers that cannot be written as a fraction. Like what?
Pi.
Pi. Square root of 2. What about this number? Now, I know that people have told you your whole life that this is a letter. That's because it's true. It is a letter. Okay? But in Algebra 2 and on, sometimes in Algebra 1, I'm not sure if you looked at that stuff then, but if you didn't, you didn't have to. Okay? But E is a number. It's a letter used to represent a number. Okay? And when we get to logarithms in second semester, we're going to talk about what this actually means, where it comes from, things like that. But it is a number that cannot be written as a fraction. Okay? These all lie in the real number set. So like this whole paper is the real number set. Wait, if there's real numbers, does that mean there's fake numbers? No, not fake, but another kind, and we'll talk about those. Foreshadowing. Okay?
Yay.
Any questions about that? So now that you know what we're talking about when we talk about this, let's talk more specifically about how to write some of these sets of numbers. Okay? We're going to deal with inequalities, right? If I say -3 is less than or equal to x, is less than or equal to 3, what does that mean about a value for x? Like in English, how can we say that? X is between -3 and 3. Is -3 and 3 included as part of my x values? Yes. So could I just say It's -3, -2, -1, 0, 1, 2, and 3. No. Why can't I say that? That's correct. It doesn't include all the numbers in between -2 and -3. It doesn't include all the numbers between 0 and 1. So let's make this clear. This is not right if I say what numbers are included here. It's okay to say all the values in between -3 and 3 inclusive, which means I'm including the ends, right? But it's not okay to list them like this. That's bad. You could say all real numbers between -3 and 3, absolutely. Okay? What about this? -3 is less than x is less than 3. How could I say that in English? So all the numbers between -3 and 3 that aren't -3. Oh, so I don't count the ends, right? Do I have to specifically say I'm excluding the ends? Or is it enough to say all the numbers between -3 and 3? Do you remember the word I added up here when I talked about this one? All the numbers between -3 and 3, inclusive. That means I'm including the endpoints. All the numbers in between -3 and 3 would be this one. Does that make sense? Okay. Now, we talked a little bit about this the other day when we talked about domain and range of our parent functions. I could write this sentence right here in interval notation instead, right? And it would look like -3 to 3 with a bracket here and a bracket here, right? Why is it a bracket?
Because we know where it stops.
Because it's included. Those ends are included, right? It's x is less than or equal to 3. So 3 is part of my solution. Well, how would this one look then?
In parentheses.
Yeah, -3 to 3, like that. I mean, I could go real crazy here and say like this. Whoa. What would that look like?
It would be parentheses first and then up there.
So like this?
Yeah.
Parenthesis here and a bracket here. Is that even allowed? That looks goofy.
It's allowed.
So do I, but that's okay, right? Okay, so are we okay with that?
Yeah.
What if I said, instead of something like this, what if I did this? Do you remember what that means? How would I write that in inequality notation? It's everything, what direction from 2?
Away.
To the right. So what symbol do I use for that? Yep. X is greater than 2. Wait, is it greater than or equal to? Is it filled in or is it open? It's open, so is it part of my solution? No. So it's x is greater than 2. How would I write that in interval notation? Where does it start? 2. Is 2 included? No. And how far does it go? Infinity. Does that make sense? Are you lying? Okay, good. How about that? Let me scoot it up a little. How would I write that in inequality notation? Where does it start?
-3.
Oh, excuse me. Yes. Like that?
To x.
X?
Which is less than or equal to 4.
No. Yeah.
Like that?
And you put brackets.
Put brackets on here? Okay, so if we're talking about inequality notation, that's done, right?
Yes.
Now let's talk about interval notation. And she's right then. Bracket, -3, 4, bracket. On a number line, am I allowed to have an open circle and a closed circle on the same graph? Yeah, it would be that way up here, right? Okay. Now there's one more kind of notation that we haven't really talked about because we kind of really have. Okay. This is inequality notation right here for this one. Let me show you what set builder notation looks like. How different are these two? If I did this, how different are they? They're not at all, right? This is saying somebody was bored and wanted to draw some really pretty brackets. I'm just teasing about that. I don't know why we do that. Okay? But set builder notation, we have brackets. And then we say, hey, we're going to use an X. That's the variable we're talking about. And this line right here, it's just a vertical line. That's all it is. That means such that. All the X's such that X is greater than 2.
Okay, so the X and Y has to be the first.
Yes. Yes, they do. Okay? That is called set builder notation. And if you are looking in your book, some examples of that are on the top of page 6. Okay? If you're not looking at your book, that's fine. I just wanted you to know where it was. All the properties we just covered are on page 5, 4 and 5 and 6. Okay? You have some problems in your book to do. They are listed on the side board. Make sure you get those written down so that you do the right problems for tonight. Do you have any questions about what kind of numbers we are using? What set builder notation, interval notation, and inequality notation? Are there any questions?